Welcome back to another geography lesson. Today we're going to continue with the Mapwork calculations, and today we're going to concentrate on bearing, magnetic declination and magnetic bearing. Before I continue with this section, you're going to need the following stationery to be able to do these calculations. You're going to need your protractor, you're going to need a calculator, and you're going to need your ruler. Now let's continue looking at the following calculations that we're going to discuss today. If you look at it, if you just read with me, note the true bearing, the magnetic declination, magnetic bearing, and positioning, and the map sheet reference calculations can only be done on a topographic map. And that topographic map is a 1 to 50,000 map. Now you will get this map with an orthophoto, but these calculations will only involve the 1 to 50,000 topographical map. Okay, vertical exaggeration, this will be discussed in the next lesson. We can do from both, but I'm only going to concentrate on this information in today's lesson. Now, if you look at true bearing, it's basically measuring the angle in degrees. Now, true bearing is very similar for me than direction, but we're just using the protractor and we want to see the degrees. Now, we calculate true bearing with magnetic declination to determine the correct direction we are going and help us to find the correct way. Now, the correct way to measure bearing is 3 steps that I like to follow. Very similar to direction. Before I'm going to go and have a look at the steps from bearing, let's just quickly revise direction. Remember, north is always on top of your map, east situated over there, south over there, and the west on your left hand side. Now, if you can remember from my previous lessons, I've asked you to follow 2 simple steps with direction. If I ask you to go and calculate determine the direction from the reservoir to the reservoir over there and the grid just southwest of it. What's your first step? Draw a north-south line. Second step, draw a line from where and to. There's north, there's south. There's east, there's west. So the direction from the reservoir over there to there will be southeast. We follow 2 simple steps. Draw your north-south line, draw a line from where and to. Now, bearing, we're going to use the first couple of steps as well. And if we quickly go back and look at these steps, draw a straight line joining A and B, draw a north line through the point, a north-south line, place your protractor on the top of the north line and move clockwise. When we look at our 16 cardinal points, we can, there's one, let's quickly just look at our 16 cardinal points. There's north, east, south, west. So this can represent a protractor as well. There's 0 degrees, there's 90, there's 180, there's 270, and 360. Now keep in mind, step number 4, move your protractor in a clockwise direction. From there all around to there. If you forget just keep in mind, have a look at your watch, the way your watch are moving. Now let's quickly go and do an example of bearing. If I ask you to go and calculate the bearing from Trichbeacon 198, I hope you remembered that a Trichbeacon represents altitude. It consists of two numbers. The Trichbeacon 198, printed in italic and not bold, is the Trichbeacon number. The actual height is the 156.6. So let's state the question asks, calculate the bearing, determine the bearing from Trichbeacon 198 to Trichbeacon 196. What's our first step that we need to do? Our first step is go and draw a north-south line. Our second step is draw a line from where and to. Our first step is using your protractor and placing it on the north-south line. And lastly, our final step is clockwise. So we're moving, as you can see, from 0 degrees all the way around to where we joined both lines. And if you can read over there, it's 143 degrees. So the bearing from Trichbeacon 198 to Trichbeacon 196 is 143 degrees. Now sometimes they might ask you to calculate the bearing. That's when we want to add once it goes past 180 degrees. And I'll quickly give you an example. Let's just quickly remove this one over there. It's straightforward, and just follow your steps. I just need to erase these lines over here. And erase that little bit over there. Now let's say, for instance, the question states, calculate the gradient from spot height 139 to the reservoir situated over there. Now what's a reservoir? It's to save water. Now our first step clearly states, what do we need to do? Draw a north-south line. So we do it over here. Our second step, draw a line from where and to. And our first step is placing your protractor on your 0 degree line, north-south line, and you move clockwise. Now let's just quickly go and have a look at that. Use your protractor, you place it on your north-south line as such. Now as you can see, the movement that we need to do is in a clockwise direction. Now there's 0 all the way around to over there is 180 degrees, as you can see on your protractor. Now turn your protractor also clockwise, and once again place it on your north-south line. And as you can see, and you continue doing the reading, there's 0 degrees, 10, 20, and you continue up until where the line is from where and to. And if you read with me over there, it's 117 degrees. So what do we need to do? 180 plus 117. You get out your calculator. And that gives us, just want to have a look again, 297 degrees. If you do follow the steps, I will be 100% sure that you won't make a mistake. And keep in mind, when you draw your north-south line and a line from 1 to 2, please use only a pencil. Let's just quickly do another one, just for the sake of it. That we can be 100% sure, then we can move on to magnetic declination. So let's say the question states to determine the direction, the bearing from Trick Beacon 179 to Trick Beacon 198. Now what's our first step? Our first step is to draw a north-south line. Our second step is draw a line from where and to. Our third step, placing our protractor on our north-south line and moving clockwise. As you can see over there, it's on the 0 degrees over there. We're moving in a clockwise direction. Up until there, it's 180 degrees. Take your protractor, move it clockwise, and start reading from there because we're moving in a clockwise direction. 0 all the way to 60 degrees. So it's 180 plus 60. We go to your calculator. 180 plus 60 equals 240 degrees. And that will be your final answer. Now that's bearing covered. Remember, grade 12s, follow the steps in your books. Draw the straight line, your north-south line, place your protractor, the 0 on the top of the northern line, and move your protractor in a clockwise direction. Very importantly. Okay, let's continue. There's another map that we're going to use in a bit. Now, when we look at magnetic declination, it's very important that we need to understand what magnetic declination is. It's the angle between true north and magnetic north. There's a difference between the two. This angle is calculated when the map is drawn, but the position of the magnetic north changes. So what we need to do is, we need to calculate what the magnetic declination is for the current year. Now, first of all, we're going to look at the current year, and definitely that's 2017. You will find that the magnetic declination for the year of the map was drawn on the map. We're going to look at this set of information in a bit. It appears on the left-hand side or on the bottom of the map. Now, I can almost 100% guarantee you that you will find this information on the bottom of the map. And if we quickly go to our maps, remember it's only on the topographical maps where we get this type of information. There you can see the information regarding magnetic declination. After the break, we'll quickly discuss what's been given to you on this map in detail. Stay tuned and don't go far away.